Oh, no. Don't worry. Proofs. We've got plenty of time to worry about proofs. Don't worry about that. The next step, we were talking about this first hour about the natural progression. We were talking about this first hour about the natural progression of where we're at and how we're working through all this. Each section that we worked on leading up to this point, whether it was adding, subtracting, multiplying, or dividing, all kind of led you to being able to solve for x, just like you guys have done with linear equations. You had to learn how to add, how to subtract, how to multiply, how to divide. You had to worry about order of operations. You had to do all that kind of fun stuff before you could do x plus 2 equals 5. It's the same natural order. When we did this, excuse me, you've seen these style problems before. In fact, the first example comes from an Algebra 1 textbook. Now, when you saw something like this, what would it have been, two years ago or so at least? Somewhere in that neighborhood? You had 1/3 x plus 1/4 equals x minus 1/6. And whenever you did things like that, you went through the process like you would always. You'd notice that you have variables on both sides of an equation. You'd pick on a little guy, and then you would work backwards through the order of operations. Do you think any of that has ever changed? No. But what has changed a little bit is the fact that now there's a method to get rid of the fractions. Okay? If I look at all that, the 3, 4, and the 6, what's the next least common number they'll have in 12? If I multiply that entire thing by 12, what happens to the fractions? They go away. I've been doing this forever, guys. The only thing that's going to be different is that it gets a little bit weirder with the giant, complex fraction problems. So if I multiply, I'll do this long form. When we take this, and you multiply everything by 12, when you're dealing with equations, the rule is that one side is always jealous of the other. So whatever you do one, you got to do the other side. So it's basically just distributing it all the way across. And I'm going to write it out long form, first 2 times, and after that, be like, oh, yeah, this is easy. So you send it over. You get 12 over 3x. 12 over 4. And I didn't really need to write down 12 times 1, did I? How does what work? Well, one group of 12 would equal? Well, that would be 1 plus 12, but thanks for trying. So, what's 12 over 3? 12 over 4. And 12 over 6. Whew. I know. It's Friday. I'm trying to keep it light and easy for you. Now it's easy. Now you have no fractions to worry about. Piece it together. What are you going to move next? The x's first. Well, you can move the 2. It doesn't matter. I guess it doesn't matter. Subtract the 4x and the 2. We get 5 is 8x. 5/8 is x. You're done. And this is the other nice thing about when you're working with these, is that you're going to get fractional answers, not decimals. Decimals are awful, except once in a while. Fractions are your friends. What's that? Except once in a while, yes. It's a bait and switch thing we've always done. Just put it in decimal form. Again, this is nothing that you guys haven't seen. You've done all these operations before. It just starts to look a little bit weird. Okay? Same idea. What are you going to multiply everything by to get rid of the fraction? Well, sorry, let me get ahead of you. Write it out first. Why 12? Because you said so. Okay, all right, why do you say so? Because it's correct. Why is it correct? Can't really argue. How did you come up with the number 12? In stereo, that was well done. Thank you. Yeah, at least common denominator. The next number that both 3 and 4 go into happens to be a 12. Now, this time, I'm not going to write it out long form because just like you did yesterday when you were just combining like terms and stuff, you would look and say, all right, this had an x plus 2 and needed an x minus 1. Well, it has a 3 in the denominator, which means 3 times what is 12? 4. So it becomes 4x plus 4x plus 3x is 21. And again, the reason why it's 21 is because it's 12 times 7 over 4. Well, 4 goes into 12 3 times. So this is real tough. 4 plus 3. I am asking a lot of you. Something good. I'll agree with you. Quick question. Do I have to worry about 3 for an answer for this? Why? Okay, but where's my variable? It's 3, but you're right, it's on top. What's the top number called? Numerator. Can the numerator be any number? What can't the denominator be? Can't be 0. So is 3 is 0? No, it is x in the denominator. So do I have to worry about that whole excluded value thing we were talking about the other day? Will we have to worry about that? Yes. It's crazy how I say these things earlier in the week. Really? Remember I said, hey, where's your vertical asymptote? Oh, there it is. Thank you, sir. You're paying people off, aren't you? Ooh, let's make this even scarier. It's not a Nine Inch Nails song, it's a sign. Wow. Yes, I had a reference to a Nine Inch Nails song, yes. Anyway, when you guys did this stuff last year in geometry, or even in previous years when we first worked through things, one of the things that you guys did is that you would have to solve for the, in this case, let's see if you remember this one. Are you solving for a side or a hypotenuse for this one? Hypotenuse. You're solving for a hypotenuse. Remember, sine is opposite. Remember SOHCAHTOA? So sine is opposite over hypotenuse. So just thank you. Unless it's a cosecant or a co. Now, one of the things, hey guys, one of the things that you guys had here is that when you worked with this stuff last year in geometry, these are what we called trigonometric ratios. Ratios were sets of fractions that were equal to each other. Now, I don't know if Seb showed you guys this trick. I know that I use this trick all the time. Does that change anything when I put that over 1? So, does it change when I do this? This is just real quick off the side here. Is this a true or false statement? It's true. 1/2 is equal to 4/8. It's the simplified version of it. Now, did you guys ever see this trick when you flip things on the diagonal? Yes. So, watch what happens. If I flip them on the diagonal, I get 1/4 is 2/8. Is that true or false? It's also true. Okay, let's flip the other way. If I flip it going this way, I'm going to get 8/4, which is, excuse me, 2/1. Is that true or false? You didn't know this? I know. First hour was amazed by this too. Simon. Yes. That's the whole idea. What's happening here is that in geometry, do you guys remember when you guys did the slide rule stuff with Sam last year? Did altitude, hypotenuse, things like that? Slide rule, geometric mean? Vaguely. I mean, if you don't remember all those terms, it's not a big deal. But you had things that are called means and extremes. Ratios are products of means and extremes. Don't ask me which one's which, I forgot, but it just sounds cool. But what happens is, whatever, you can always exchange things on diagonals. That's why it works. So like you were saying, this problem here would have been just flipping the x and the sign of 34, excuse me. And that's how you were able to solve that out. Or if you think of it in terms of long form, how do you undo multiplying by x? I'm sorry, dividing by x. Gee, I wonder how that works. You would have had to multiply both sides. And then how do you undo multiplying by sign? You would have divided. This was the shortcut of things. Basically, it was one of the preludes of showing why, when fraction equals fraction, cross multiply. That's why all that worked. Because of all that. Because you can flip these on diagonal and it doesn't change. Guess what happens with the problems in here? They're in here somewhere. Well, I got out of sequence. No, I flipped out of sequence by mistake. When you get to something like this then, isn't that the same basic idea? You've got fraction equal fraction. When you have fraction equal fraction, that means you can exchange them on the diagonals as nothing changes. Or to solve everything out, all you have to do is just cross multiply. You guys remember that, right? Okay. Does it change when you have quadratics and stuff in there? No? Do I need a common denominator for anything like that? No. So when I cross multiply that, what do you get on the left side? You get 2 times quantity x minus pi. You guys are saying 2x minus 2y. On the other side, you get x squared minus x. So this is 2x. Now, how do you solve a quadratic equation? Set it equal to 0. Gee, you're going to see a lot of that again, aren't you? So I'm going to move everything to the right side because I don't want to deal with negative first term quadratics because that's always a big pain. So if I do that, I can subtract the 2x, add the 2. We get 0 is x squared minus 3x. What times what's 2? Add together to get negative 3. Negative 2, negative 1, sir. Which first part? Here? When you ever have fraction equal fraction, you just cross multiply. Right. What are your zeros then if your terms, back to this again, your terms are x minus 2, which generates 0 of 2, and then the term of x minus 1 gives you a 0 of 1. Now this is where you'll have to start to going back to the original problem and looking. Does 1 work? No. Why doesn't it work? Because you get a 0. Can you divide by 0? No. So you get an answer that's not an answer. That's what we call an excluded value. A lot of times in these problems, you're going to see that. When you get 2 solutions or even 1 solution, you want to take a second, go back and double check to see if it works. Sure. Yeah. I just went with the 1 first because I know that I have x minus 1, well, plus 1 minus 1. But I have 0 in the denominator. So I know right away, I do that one first because I catch it. And then I just think of it, well, what's 2 minus 1? 1. What's 2 squared? 4. And you're like really worried that you're going to get that wrong, and that's okay. And that's 4 minus 2. 2. Okay. Oh, I'm sorry. Excuse me. What's that? Correct. Yeah, so you have 4 minus 2, which was, hey, that didn't work out at all, did it? Hmm? Oh, yeah. Duh. Good morning. Devin, you okay? Oh. Devin, you okay? wants to do. All right, what do we do now? First of all, when I look at this problem, do I have to worry about an excluded value? No. Why? Yeah, there's no x in the denominator. You're going to have a lot of this stuff bouncing back and forth like that. Okay? And that's a quick thing as you're writing these things out. As you write down a problem, you'll notice, okay, I don't really have to worry about excluded values here because there's no value in the denominator. There's no variable. How do you get rid of the 3 and the 5? Very good. You multiply everything by 15. Top tip. Most of you guys write down problems right next to your margin line on your paper, don't you? Now, as you, more often than not, you guys do that. In this section, I will make a suggestion because some of our terms will be multiplying out because of the common denominators. You'll have larger those two. You have larger common denominators that you'll be multiplying out by. Why not move this over a little bit from the margin so you have a little bit of space? When we get to one that has more junk in the bottom, you'll see what I'm talking about. So if I multiply everything here by 15, what's the first fraction yet? It becomes 5x. The second fraction is? So you have a 5x minus 3 plus 2 equals 30. Very good. What are you going to screw up here? The negative. For some reason, you guys will always forget to distribute that negative to the second term. Please, if you do that on a regular basis, just draw the arrow. All right? So you get 5x minus 3x minus 6 is 30. Excuse me. All right. Once again, not very difficult. It's a process of which you guys have all seen. You just didn't realize it's what you've been doing all along. Let's get to one that's a little bit weirder. Waiting. Yeah, what the fuck is that? There's no fun in that. All right. All right. Go back to the other one. One of the things that this textbook does, and a lot of textbooks do, you might have noticed this by now, when they put negative values on fractions, that negative value tends to get put right in front of the fraction bar, which means it normally what I would say, it can be either the numerator or the denominator that's negative. Generally speaking, it's easier on you if you always put it in the numerator. You guys have seen that, right? I think we've talked about that before too. So when I write this one out, I would say it's 4 over x plus 5 over 2 equals negative 11 over x. Yeah. Well, let's first think, what are you going to multiply by for your common denominator? 2x. Because you want to get rid of that denominator. You want to get rid of everything in the denominator. So the idea is, well, what do they have in common? They have nothing in common. So the common terms will be when you multiply it all together. That's 2 and an x. So now this looks a lot like what we did yesterday, except for the fact that there's an equal sign. All right. First fraction has an x, it needs the 2. Second fraction has a 2, it needs the and then the last fraction has the x, it needs the oh no, what do you do? Can negative 6 work? Is it, or at least let me rephrase that, is it an allowable value? Okay. Would it take terribly long to double check to see if you mathed right? No. So check it real quick. This is one of those sections that always says check your answers because sometimes you're going to get that answer that's not an answer. So it's always take a second to do it. So if you do that, you get negative 4 over 6 plus 5 over 2. I know that I need to end in a sixth, so do I have to really worry about the common denominator? Oh, wait. Bye, Devin! Have a good weekend! So what do you multiply the same? If I know that I'm going to have a common denominator of a 6, what do I have to multiply the second fraction by? So you get negative 4 over 6, 15 over 6, which happens to be. Because our value of x was negative 6, and it works. We math. This out of the way here. Okay. All right. You knew it was going to happen. This was the problem style that I would suggest that you move over from the margin bit. You see why I'm saying that? So move it away from your margin a little bit so you have a little bit of space. Do you have to? No. The other thing as you're going through this, as you're writing it out, in the back of your mind start thinking, you have variables in the denominator, which means you're going to have some sort of excluded values. Which means, right off the bat, what can't x be as you're writing it down? It can't be 1 or negative 1. Are you okay with that? Yes. Now, did you write this down when you wrote 12 over the x squared minus 1? Did you factor that right away? See? What I tell you, if you do little silly things like that, it helps out. Because then you know you can get your common denominator quicker. What's that 3 over? It's over 1. So what do I want to multiply this entire thing by to get rid of our fractions? X plus 1, x minus 1. I want to multiply them by them both. Because if I only multiply it by the x minus 1, I would only get rid of this value. I'd have to multiply it by both of them to get rid of everything. Right? So by multiplying out by your common, it goes back to the same idea of that first fraction has the x plus 1. It needs the x minus 1. So you have 4x plus 1, x minus 1. Fraction in the middle has them both. So what do I write? 12. And then fraction on the far right then needs them both. But am I going to write it as x plus 1, x minus 1, or am I going to write it as x squared minus 1? You're right, it would be whatever I feel like, but which one would be easier? Remember how we did that, I think it was the one earlier today, how we already had it factored out where I had to multiply it by the 3, that second number 9, where I just wrote down the factor form of it already, the FOIL out form, excuse me. It's just shortcuts. You know, you don't have to do it that way, it's just easier. Combine like terms, FOIL out. You get what? 4x squared. 4x minus 1, so it'll be negative 4x plus an x gives you how much for your middle term? Negative 3x. And your last one is 1. Other side we have 12. 3x squared. Oh no, what do I do? Nothing. Yes, cry, run away. What do you think we should do? Set it to 0, pick on the little guy. Which one are you going to move everything to the right or are you going to move everything to the left? Move everything to the left. It'll be easier on it. So I subtract the 3x squared, then I'm going to subtract 9. With any luck, we get convenient that we already factored one like that a little while ago, isn't it? I planned it. Imagine. What times what's negative 12 you add together to get negative 3? Oh yeah, did I say 12? Yeah. Sorry, I was looking at the 12 when I said it. So I was wondering why you were. What times what's negative 10 that you add together to negative 3? Negative 5 and 3. 2. Do as I write, not as I say, you'll be fine. Don't watch the video on audio only. There you go. Where are your zeros? 5 and negative. And then you have second. So we move this down. So at quick glance, it looks like neither one of them is going to be an issue because when you put them in the denominators, you're not going to get zeros. But the only thing you have to worry about is just substituting in. Let's see here. So we get, what is that, 21 over 6, which is 12 over 24 plus 3. That's awesome. Well, divide those by 3, you get 7 halves. Oh, look at that. What did I tell you about fractions? They're your friends. Oh, don't whine. I know. And then go through the negative 2, and we'll go through. I want to do another example. Yeah, these in this case, the denominator will matter because when you have the denominators, if you want to get rid of them, it makes the math easier by multiplying up by the least common denominator. Okay? And then the denominator is important so that way that's what gives you those excluded values. That gives you the values in x that it could be, but it might not be because you can't get 0. The numerators don't matter as much because in the long run, the numerator can be 0, and that's fine. Take a minute and go for it. Running short. What times what's 20 that you add together to get negative 12? Negative 2 and negative 10. Hey, isn't that convenient? Hey, here's a dead giveaway, guys. If they have trinomials as well as terms all written at the same time, I bet you some of the terms are going to work. Because they're not going to make this that terrible. I mean, it's just terrible light. Yeah, I just made it up. Remember the whole 80-20 thing? What do you multiply everything by then? Oops. First fraction needs a what? Second fraction needs a what? Third fraction needs nothing. Gee, what do you think you're going to do next? Distribute, combine like terms, exactly. Yes, it does sound like that. Wait, what? What did I do? What's that? No, what'd you say? What'd you do? Oh, it's okay. That's all right. So 2 minus 3 is negative 1. Negative 1x, 26. So negative 1x is, what's that, negative 20? That works, doesn't it? I will tell you this, on Monday, let me show you here. Monday we'll get to that because I know you're heartbroken. What's that? Oh, I'll go back to it. We didn't have time to get to this one, but what I want you guys to do this evening, or who am I kidding? What you guys are going to do on Sunday evening or Monday morning? Or flex on Monday. I know what happens. I get it. That'll be Monday, right? In this section, 9-6. Guys. Go 42 through 50 on those, please. There's no complex fractions to worry about. Like I said, we'll get. Yeah, I know. We'll do a couple of those on Monday, and on Monday we'll also do. I'll show you a couple shortcuts for those. We are still planning on testing through all of this. I think we have ours set for Wednesday, right? We'll have on Monday when we finish out the complex. We'll go back over. We'll go back over graphing because I know we've been talking about asymptotes and things like that. We need to go back over it so you can go through the sequencing of that. And I'll have a review sheet for you guys Monday that we'll be able to go through in class all day Tuesday. Yeah, it was. It was a year ago, so that's the problem. I know it's bad. I know, but it doesn't get that old, does it? Oh, you guys turn on me so fast. I apologize. First hour we talked about the iguanas falling out of trees in Florida. Did you hear that? Iguanas were falling out of trees in Florida because they were freezing. You know what I'm talking about. I saw it on the news this morning. And they're not dying. They get really cold and they just fall out of the tree. So people are, the good Samaritans are walking around picking up iguanas and putting them in the sun so they thaw out. It's a thing. I'm telling you, this is a true thing. Dirks, I know you think you really. All right. I know this is a whole thing. I make up a lot of stuff. It's. Well, they put in the sun and they're fine. It's just they get a little. They're cold-blooded. They don't know what it's like to be cold. It's 40. Well, no, it's there's some parts of it. I think there's like Tallahassee, so it's like in the 20s. So you get that. Apparently, you have no problems with this. What's wrong with here? Anytime.